Hello friends, so welcome to day 13 for solving problem of the day from GFG. So let's look at the problem of today. Okay, so this is a binary tree problem. So given a binary tree of size n, where each node can have positive or negative values, alright, convert this to a tree where value of each node will be the sum of the values of all nodes in left and right subtrees of the original tree. The values of the leaf nodes are changed to 0. Okay. So let's understand the question using an example. Okay. Yeah. So take this example. Take my output. All right. Okay. Now see, we have given a tree. Okay. All right. So what I have to do? I have to make each node. I have to replace actually. I have to replace each node's value with its left left subtree sum and right subtree sum. Now what are left subtree sum and right subtree sum? So that is we are going to know while we just solving the question. So let's start the solving the question by this diagrammatic method. Okay. So I will start from here. So as this is a root a leaf node, right? Because it has two sub nodes as or two children nodes as null, right? So its left child node and right child node are null. So what the question is saying that if it is a leaf node, I will replace its value by 0 and I will return 8 to my parent. Okay, so 8 is returned here. Now here, this is also leaf node. So I replace this value by 0, I will return -4 here. Okay, now what will I do? I will calculate the sum of this one and this one. I will return 8 plus -2 plus -4. Okay, so what is the value? It's uh, um, uh, 4 minus 2, 2, right? I will return 2, but I will replace the value by this plus this, that is 4. Okay, so you have to notice that I am returning the sum including this node's value. Suppose up to this left and right, so my left tree sum gives me x and right tree sum, right subtree sum give me y value, and I have z value. So I will replace my value with x plus y and return x plus y plus z. Okay, so that is one thing to notice, that I am returning x plus y plus z, but I am replacing my value with what? X plus y. Okay, so now I will replace my value with 8 plus -4, which is 4, and I will return which? 2. So 2 is returned here to parent, and similarly for here it is leaf node. Replace this by 0, return 7. Replace this by 0, return 5. Replace this by 7 plus 5, 12, and return 7 plus 5 plus 6. Okay, so 18. So it will be replaced by 12 and it will return 18. So replace works on left sum plus right sum, and return works on left sum plus right sum plus my value. Okay, so this is the two key points for solving this question. So this question is very easy if you understand this thing. Okay, so I have written 18 here and I have written 2 here, right? So for this node I am returning, so 2 reaches here, 18 reaches here. I will replace this value by 2 plus 18, that is 20, and I will return, that is my answer will be 2 plus 18 plus 10, that is uh, 30, right? So my answer is 30, but I don't have to print 30. 30 means actually sum of all the nodes is actually 30. Okay, so you are actually sending what from here to here? You are sending the sum including this, right? From here you are sending the sum including this. So from here you are actually sending the total sum of left subtree. From here you are sending the total sum of right subtree of which this node, and you are lastly adding left sum plus right sum plus your own value, that is 10, and sending it. That is, you are actually giving your total answer, total sum. But that is not usable here. I have just to just replace the values. So I'll return this, but I will not do anything with return. So see, when I will code, you will understand. Okay. So now for sake of this question, just understand that you have to just replace values. Why we are returning values? Why we are returning the values? Let me see. Okay. So suppose I replace this with 8 and then it doesn't return the value. Suppose I replaced with 0, sorry. I replaced 8 with 0. I replaced -4 with 0. I am not returning value. Then how can I replace this value with my this sum plus this sum? I don't have anything. I am not returning anything. So how can we get the life sum and right sum, right? Right. So that is why we are yeah, we are doing this. We are returning the left sum right sum because it is to be used by my parent. Both the children are returning their sum including themselves because my parent will use it, right? That is why I am just returning the left sum and right sum. Okay, yeah. So let's see the answer here. Yeah, so it is also correct. So this is becomes 0, this becomes 0, this becomes it returns 8, it returns -4, so it becomes 4, and it returns 2. Here becomes 0, becomes 0, it returns 7, it returns 5, this becomes 12 and returns 18, this becomes 20 and returns 30. So my tree is now 20, 4, 12, 0, 0, 0, 0. So is that same? Yeah, so it's same, right? Now let's code. Yeah, let's code now. So I will use recursion. Let's expect okay, so let me call a function because this function is actually doing nothing in return. Okay, so to create a function, suppose solution which will be returning some values. This is a trick to solve this kind of problems. You have to create another function because your function is doing nothing in return. Okay, yeah. What will I do now? I am expecting that if I call solution root dot left, I'm expecting that it's a faith expectation rule of recursion. Okay? So I'm expecting that this function solution root dot left will give me what? Will give me the left subtree sum of my child. Okay, my left subtree sum. Okay, so this one when I call this function, it will expect that my left subtree sum, this function will give me the left subtree sum, that is 10 is expecting from this function. 10 is expecting from this, or 10 keeps his faith on the function that when I call it function, it will give me the left subtree sum of this one, right? My left subtree. And similarly, when I call root dot right, I am expecting that 10 is expecting that actually that it will give me right subtree sum. Okay, so root dot left is actually 2 minus 2. So I am expecting from my child that when I call this one, this will give me the left subtree including minus 2. When I call root dot right, 6 will give me the right subtree including 6. Okay, so that I am keeping faith on it. Okay, so left sum. Okay, similarly right sum. Right, so now my value will be replaced with what? Left sum plus right sum. And what I will return? I will return my sum. My sum means left sum plus right sum plus my value. Okay, that is what I am returning. Now let's keep the base case. If root is null, I will just return 0. But if it is a leaf node, I will return. I will. I will store the value of that leaf node. I'm storing the value of that leaf node, and I am replacing that leaf node by 0, and I am returning the leaf node value. So what I did for this case, I stored its value to some variable base sum. Okay, I am replacing it by 0 and I am returning 8. Right, this is what I have to do, right? So that is what I am doing here. So let's check. Yeah, it's okay. So let's run this. Compiler error. Can find symbol root.val. Oh, okay, so data is given here, right? Not val. So it's data, not val. Okay. Okay, one thing also, I have to do this part at first. Okay, because root data is changing after I am calculating my sum. Okay, because if I did it first, then here it will be left sum plus right sum, because it's assigned with left sum plus right sum, so it will be a misguide to the question. I hope you understood. So I am calculating first what I have to return. Okay, so that is what I have to return. That is why I did it here, the base sum part. I will return the base sum, so I will calculate what I have to return first, then I will replace my value, because if I first replace my value, then what I have to return actually contains my value also, so that will be misguided. So that is why. Oh, where is the, okay, so here. Okay, submit it. Yeah, we got it. So let me dry run this thing once. Suppose this is my tree, so root dot left is called, so called, again root dot left called, again root dot left called. Here when 2 called root dot left, for -4 left and right childs are null, so it actually returns which one, -4, it returns -4 and replaces value by 0. Okay, now for 2 left is done, right is called, right is called. Again for this one both childs are 0, so it replaces its value by 0 and it returns its value 5. Okay, so what 2 left and right are done, so it calculates my sum, which is -4 plus 5 plus 2, which is 3, and it replaces value by left sum plus right sum, which is 5 plus -4, which is 1, and it returns 3. Now for 1 left is done, so now it calls right, again left is called. Now here it also left node, so replaced by 0 and it returns 6. For 3 left is done, now right is called, again this is a left node, it's replaced by 0, it returns -7. So for 3 left and right are done, now it calculate my sum as 6 plus -7 plus 3, which is 2, and it replaces value by left sum plus right sum, that is 6 plus -7, which is -1, so it returns 2. And from here we returned 3, right? So it replaces value by 3 plus 2 5, and it returns 3 plus 1 plus 2, that is 6. So that is not usable, so the actual tree becomes then 5 1 -1 0 0 0 0. Okay. So that's it. So I hope you like the video, and if you like the video then please share, like and subscribe. So let's see you in the next video.